Hi guys, it's me again. I'm back. Okay, so now that you've completed lesson 1.1, let's move on to 1.2 and do some segment relationships. Now, normally I do something on a program called GeoGebra, which is super cool that we would be discovering this stuff. But I'm hoping to do that maybe on Thursday in class when I see you guys again. It's a little hard for me to do on the computer without you guys there. And be able to explain it. So hopefully when we're in class, I can show you that as a recap on Thursday of what we did today. Okay, so here's our first 1.2 segment relationship that we're going to look at. We're going to do something called the segment addition postulate. So I have it typed up there for us. It says the sum of the measures of the parts of a segment equals the measure of the whole segment. So essentially it's saying two parts will add up to a whole, which completely makes sense. But if you're like me, I need an actual visual to be able to see that. So let's draw a picture. It's going to be so much fun. Okay, now notice how this is not saying a line. It's not line addition, because you can't actually add parts of a line because a line continues forever. So we wouldn't know where it ended to add them up to set them equal to something whole. So it only works with a segment. So let's bring in our segment. Oh, do I have my pen tool on? Maybe. Oh, I'm frozen. I'm back. Okay, so here we go. Let's draw ourselves a segment. Let's call this one bat. So B, I'm going to put point A maybe here, and then point T here. So we have segment bat. Remember, it's not a line. We need a segment. So we need those endpoints on there. Notice A is just kind of hanging out closer to B. It could have been closer over to T. Could have been in the middle. We don't know. But I do know that if I take the distance from B to A, or this segment here, and add to it the distance from A to T, so from A to T, the length of B to A and the length of A to T has to equal the length of the whole segment, which is from B to T. So the two parts of the segment, I froze, the two parts of the segment have to add up to the whole. So maybe this piece was 5 and this piece is 6, then the whole segment on here is 11 when it was added together. Let's look at an example together. This is going to be so fun. I love a good solve for x too. Okay, so we have if C is between D and E. Oh, that means I should draw a picture. So I'm going to draw myself a segment, and I'm going to put point C in between points D and E. Now, it didn't tell me exactly where to put C, as long as it's between them somewhere. It could have been closer over to E. That's really irrelevant at this point. D to C is 1/2, oh, I love a good fraction, 4x plus 6. And C to E is 3x plus 1. And the whole, oh, I'm really bad at drawing those things, is thing from D to E is 44. So the whole piece is 44. I am really bad at this, so I don't know about you guys, but I'm actually going to highlight, oh, darn it. I thought that was a highlighter. Well, I'm going to highlight what I actually need to solve for, which is DC. Oops, am I frozen again? I need to solve for DC and CE. So those two lengths are the things that I'm actually going to solve for. Okay, so according to my segment addition postulate, the two parts add up to the whole. So if I take 1/2 of 4x plus 6 and add to it my other part, which is 3x plus 1, they should add up to 44. And now I can just simply solve my algebraic equation. So 1/2 of 4x plus 6 is now 2x plus 3. That was nice. Plus 3x plus 1 equals 44. In other words, 5x plus 4 equals 44, or 5x is 40, or x is going to equal 8. And some of us would just stop there and say, that was good enough, but that would be naughty, because we actually have to solve and find DC. And we need to find C to E. So D to C is 1/2 of 4x plus 6. Well, I'm going to take half of 4 times 8 plus 6. Oh, it's not writing. And then that's really half of 38, because that's 32 plus 6. And half of 38 is 19. That was kind of fun. And now it's easy to find CE. It's 3 times 8 plus 1, or 24 and 1, which is 25. So I actually did draw that right to begin with. It's shorter from D to C than it is from C to E. It would have been, I was really frozen there. It would be okay if you had not drawn it to scale, but it was actually shorter from D to C than it is C to E. And that's what it looked like in my picture. That was just a coincidence. Okay, so our answers are 19 and 24 for that one. Segment addition postulate says that the sum of the measures of the parts of a segment add up to the whole. I'm really freezing right now. My internet must be slow. Let's look at the next thing. The next term we're going to look at is called a segment bisector. A segment bisector intersects a segment at its midpoint. Wow, what the heck is that? Well, at the same time, we might as well write down what a midpoint is. A midpoint divides a segment into 2 segments. I froze again. A midpoint divides a segment into 2 segments of equal length. So maybe we should actually look at the midpoint first, and then we can go back up and look at the bisector. So I'm just going to scroll past this for a second. We will go back up and do that one. But a midpoint makes sense because of its term mid. It would make sense that if I had a segment, I wasn't sure if I was frozen or not. If I had a segment AB and I put a little point right in the middle, from A to M, the distance is equal to M to B if that point M is called a midpoint. Those segments on either side of point M need to be equal in length. So like in this example here, it says M is the midpoint of segment PQ. Notice it's always a segment. You cannot have a midpoint of a line because a line continues on forever. So if someone had written a line notation above that, it would technically be wrong. So from P to M is 1/2 of 10x plus 16. And I know that the whole thing from P to Q is 76. So I only know part of the segment, but since it's a midpoint, I technically know the other side, or both of those pieces are equal in length. And sometimes they're marked with little slashes on them to show that they're actually equal. So technically, if I take 2 and times it by this 1/2 of 10x plus 16, that's a lot of stuff going on right there in that equation, but that's why you're in honors. It should equal 76. Well, if you take 2 and times it by 1/2, essentially 2 times 1/2 is just 1. So now I'm just left with 10x plus 16 equals 76, because this is like 2 times 1 over 1 times 2, and they would eliminate each other or cancel out. I'm going to subtract 16 from both sides. So now I have 10x equals 60. Oh, yeah. 60, I'm back. So x is really 6 on here. And one of the things I wanted to find was x. I also need to find the distance from P to M. And P to M is going to be half of 10x plus 16. Okay, so that's half of 10 times 6 plus 16, or half of 60 plus 16 is 76. So my answer here is going to be 38. So my x is 6, and from P to M is 38. That also means from M to Q is 38 also. And if I knew the whole was 76, well, half of it has to be 38. So by checking that answer there of x is 6, I know I've done the problem correctly. I love a good check, don't you? Tricky. Let's go back to that segment bisector. So now that we know a midpoint has to be in the middle of a segment, the bisector is something that intersects the segment at its midpoint. So if I had this segment, let's call it cow because I love cow. So is this going to write? Nope, it's frozen. Oh, that's fancy. Look what it did. We'll call this cow. Oh, good lordy, people. My Chromie's going crazy tonight. Maybe everybody's on theirs. Okay, so that's a funny looking segment, but there it is. We'll call it cow. And I'm going to have this like ray or like another segment that maybe comes in, and it's going to bisect. Notice it doesn't have to be straight up and down. If it was straight up and down, then it would make those segments be perpendicular and there would be right angles there. It just has to come in there and bisect it. So that means it splits it into half. Remember those little marks there that I drew mean that they're half, and that my distance from C to O is actually equal from O to W. So let's look at an example of this. Okay, here we go, I'm back. It says EF, the segment, bisects AD at C. So let's draw AD, the segment, and we'll draw another segment called EF. And the point that they intersect at is C. From A to C is 5x minus 8. And from C to D is 16 minus 3x. Oh, jackpot. If that's a bisector, that means that has to be the middle. So that means those two pieces are equal. 5x minus 8 has to equal 16 minus 3x. I'm going to move this 3x to the other side because I like a nice positive x value. So 8x minus 8 equals 16. 84, I hope. Oh yeah, it does. And x is 3 for my answer, which is one of the things I wanted to solve for. But I also need to solve for A to D. But remember, each of those two pieces are equal. So if I find the length of one of them and just double it, it will give me the whole segment, AD. So first I'm going to take and fill it in for AC. And again, it doesn't matter which one you actually filled into. So that's going to be 5 times 3 minus 8. 15 minus 8 is 7. But I need to multiply that by 2 to get the whole length. So my answer is really 14. So if x is 3 and x is 14. And that concludes our lesson on there that I will be teaching you. On 1.2 that I'll be teaching you. So what I'm going to need you guys to do now is at the end of this play pause it, there are 4 examples that you guys are going to try to do, and you're going to submit your answers into those questions at the end of this Play Pause It to see if you've got them correct or not. It'll be super fun. All right, have a good day, guys, and I'll see you again on Thursday, and I'll be there. Oh dear, what's going on now? I got so much stuff going on my computer. Craziness. Is this going to close out? Here we go. Bye, guys.